Hi, in this lesson, we'll take a look at how we can use arrays to develop algorithms. In the last couple of lessons, we saw how we can use various loops, such as the standard loop shown here, to traverse all the values in an array. Once we access the values, we are able to start to do some analysis of the array. In this lesson, we are going to look at some common techniques used in array analysis. There are many common algorithms using arrays. Notice that many of the algorithms follow a few basic ideas: mathematical analysis, analyzing properties of the elements, and reordering elements. We will take a closer look at each of these concepts in this lesson. The first group of algorithms deals with analyzing numbers, for example, finding a sum or average. The basic format for this category is to initialize a value before our loop, then perform the calculation inside our loop, and finally report our results at the end. Let's take a look at this example. Here, we are going to take a look at how we can calculate an average. Recall that average is simply the sum of the values divided by the number of values. To sum our values, we create and initialize the sum at 0 before our loop. Next, we loop and access all of our values in the array and add them to the sum. Finally, after the loop is completed, we can print out the average by dividing by our count. Don't forget to cast one of your values to a double so that we don't lose our decimal point. Analyzing properties of an array is similar to mathematical analysis. We create a tracker variable before we start our loop, then often use conditional statements inside our loop. Our tracker variable can take many forms, such as a Boolean if we want to check if a value exists, or an integer if we are checking how many times a value exists. Let's take a look at an example. In this example, we want to see how many A's a student has received. Notice how we're using an integer initialized at 0 as our tracking variable. Inside our loop, we check each value of our array to see if it meets our criteria, in this case, if it is an A. If it does, we increment our tracker variable up. After we traverse the array, we can then report the number of A's that we found. Oftentimes, we may need to look for a specific value, such as the minimum or maximum in an array. We can combine the ideas of our mathematical analysis and property of a value to solve this problem. Notice in this example how we assume the first value will be our minimum by setting the variable min_index to 0. Then we start our loop at index equals 1. While you can track the minimum or maximum value, tracking the index provides more flexibility for analysis later. Another common array algorithm involves reordering or reversing our arrays. While this can be done in a few different ways, a common method is to create a new temporary array where we copy our values over. Once our new order is copied into our temporary array, we can overwrite the original array with the new array. Here's an example of how we may reorder our array by shifting the elements in the array to the right by 1. When finished, our numbers array will be 5, 1, 2, 3, 4. Let's take a closer look at each part of this algorithm. Our first step is to create a new array that is the same size as our original array. Notice we just used default values to create this array. Next, we loop through our array and we assign values in the new position in the temporary array. Be very careful with the edge cases. Notice how we stop our loop at the second to last element of the original array and assign it to the last element of the temporary array. Since our loop goes to I plus 1 in the temporary array, our last value of I needs to be the second to last index value so that when we add 1, we don't go beyond our index. At the start of our loop, we see that the temp index is initialized with default values. Our first pass through the loop maps number 0 to temp 1. In this case, the number 1 into temp index 1. Next, the number 2 gets mapped to the right one space in the temp array, followed by the 3, and finally the 4. Notice now we are at the end of our temp array, but not the end of our numbers array. We now need to deal with this edge case. Our edge case involves wrapping the number 5 from the last item to the first item. We handle this outside our loop. Once our temporary array has the values we need, we can then copy the array back to the original array. Finally, we can print out our results in the new order. Oftentimes, we need algorithms that compare one value of the array to each of the other values in the array. This can best be accomplished by using a nested loop statement. Let's take a look at an example where we can check to see if our array has duplicates. In this case, we are using a Boolean initially set to false as our tracker variable. Our outer loop goes through each number from the start of our array to the second to last element of our array. We need to be careful not to compare the element to itself, so our loops are offset by 1. Our inner loop then starts at the element after the outer loop element and continues to the end of the array. For example, the first pass of the outer loop will select the number 1, then the inner loop will compare starting at 2 and continuing to the number 5. The last pass of the outer loop will select the number 4, then the only comparison it will make is to the number 5. If a duplicate is found, we set the Boolean to true. After we complete our loops, we can report out the results. In this lesson, we took a look at several common array algorithms. It is important to be familiar with these algorithms, as you will find many uses either directly or as a slight variation. Now that you've learned about common array algorithms, let's get some practice using them in the editor.